Hello, in this lecture we'll find out the radius of the semicircle. In the drawing we have a semicircle. We know that line segment PA equals to 6 units in its length, and also line segment PA is tangent to this semicircle at point A. In addition, we know that line segment PQ equals to 4 units in its length, and PS cuts the semicircle at points Q and S. In addition, you know that QS equals to QC, and this is angle PAB that is equal to 90 degrees in its size, and this is angle CQB that is equals to this is angle SQC that is equal to 90 degrees in its size. Again, our mission is to find out the radius of this semicircle. So first of all, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 10. According to rule number 10, in any circle, if AB is any chord in the circle and PT is a tangent to the circle, then the following equation is true, that PT square equals to PA times PB. So here in the drawing we have the common external point, point P. Point P is an external point in relation to the circle. So from the common external point, point P, we have tangent PT to the circle. Tangent PT is tangent to the circle at point T, and from the same point, point P, we have line segment PB that cuts the circle at points A and B. So in this drawing, the following equation is true, that PT square equals to PA times PB. Okay, again, PT square equals to PA times PB. Actually, we can implement rule number 10 in our drawing. Why? Because in our drawing, if you focus on the common external point, point P, from the common external point, point P, we have tangent PA that is tangent to the semicircle at point A, and we also, from the same common external point, point P, we have line segment PS that cuts the semicircle at point Q and S. Therefore, all the requirements of rule number 10 are met. For that reason, we can implement here rule number 10. According to rule number 10, in our drawing, we'll get that PA square equals to PQ times PS. Repeat again. If we focus in our drawing at the common external point, point P, we can implement here rule number 10. According to rule number 10, in our drawing, we will get that PA square equals to PQ times PS. This equation is the implementation of rule number 10 in our drawing. So, PA equals to 6 units in its length, according to what is given in the equation. Therefore, PA square is 6 squared, it is 36. And it is equals to PQ. PQ is 4 times PS. PS, from the drawing, it is very easy to see that PS in total equals to PQ plus QS. That is to say, PS equals to PQ, that is 4, plus QS. So in total, PS equals to 4 plus QS. So actually we found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we'll divide this equation by 4, and we get that according to this equation, 36 over 4 is 9. 9 equals to 4 plus QS. Here we'll subtract 4 from this equation, and finally we'll get that QS equals to 9 minus 4, that is 5. Actually, we found out that the chord QS equals to 5 units in its length. But because of the fact that it is given us the question that QC equals to QS and QS equals to 5, therefore QC must be also equal to 5 units in its length. In the next step, I present to you a new rule, or a new rule number 3, and we will implement rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have the straight line AB. If we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle alpha and beta. So alpha plus beta in total must be equal to 180 degrees according to this rule, rule number 3. We can actually implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the lower side of the straight line PS at point Q, at the lower side of PS at point Q, the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles in the lower side of PS at point Q to 180 degrees, the missing angle here must be equal to 90 degrees. In the next step, we will join points P and C together by a straight line. By joining points P and C, we created here the right triangle, triangle PQC. So I'll copy the right triangle, triangle PQC in a new page, and we will implement on this right triangle PQC the Pythagoras theorem. Here by PT is the abbreviation for Pythagoras theorem. Side PQ equals to 4 units in its length according to what is given as the question, and we just right now found out that side QC equals to 5 units in its length. So actually this is the right triangle, triangle PQC that I copied from the original drawing. According to the Pythagoras theorem, PC squared, that is the square of the hypotenuse, must be equal to PQ squared plus QC squared. So PC squared, that is the square of the hypotenuse of the right triangle PQC, equals to PQ squared. PQ is 4, therefore PQ squared is 4 squared, that is 16, plus QC squared. QC is 5, therefore QC squared is 5 squared, that is 25. So in total, PC squared equals to 16 plus 25, that is 41. So I'll write it down again, that PC squared, that is the square of the hypotenuse of the right triangle PQC, equals to 41. In the next step, I will copy the right triangle, triangle PAC in a new page, and we'll implement the Pythagoras theorem in this right triangle, triangle PAC. Here by PT is the abbreviation for Pythagoras theorem. Again, PC squared equals to 41. According to what we already found out. So actually, this is the right triangle PAC that I copied from the original drawing. In the right triangle PAC, according to the Pythagoras theorem, PC squared equals to PA squared plus AC squared. So PC squared is 41, so we substitute PC squared by 41, and it is equal to PA squared. PA is 6, therefore PA squared is 6 squared, that is 36, plus AC squared. Here we'll subtract 36 from this equation, and finally we get that AC squared equals to 41 minus 36 is 5. So AC squared equals to 5. Here we'll take a root out of this equation, and finally we get that AC equals to the square root of 5 units. So the length of this line segment AC is equals to square root of 5 units. You can write down in the original drawing that AC equals to square root of 5 units in its length. What is the length of PC? But first of all, because of the fact that this is a semicircle, AB must be the diameter of the semicircle. So I'm writing down that AB must be the diameter of this semicircle. If we define the radius of this semicircle as x, again the radius is what we are looking for in this question. We have to find out the radius of this semicircle. So we define the radius of this semicircle as x, and x is the what we are looking for. The value of x is what you are looking for in this question. So if the radius of this semicircle is x, then the diameter must be equal to, the diameter AB must be equal to 2x. So AB is 2x and AC is equal to 5 units in its length. Therefore, in total, BC will be equal to, CB equals to AB minus AC. Again, CB equals to AB minus AC. I will write it down. CB equals to AB minus AC. It is very easy to see it from the drawing. So the length of line segment CB, or side CB, equals to AB, that is 2x, minus AC, that is square root of 5. In total, the length of line segment CB equals to 2x minus square root of 5 units. So we can write down in the drawing itself that this line segment CB equals to 2x minus square root of 5 units. In the next step, we'll complete the semicircle to a circle. So we completed the semicircle to a circle, and we will extend side QC by a straight line until it touches the circle. And we will define the touching point of the extended side QC with this circle as M. So, in the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 11, and rule number 11 talks about two chords that intersect with each other inside the circle. So according to rule number 11 is true in any circle. In any circle, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times BO equals to CO times DO. Okay. Again, in the drawing, we have a circle. Inside the circle, we have chord AB. This is chord AB that intersects with chord CD at point O. The intersection point between the two chords occurs at point O. Whenever you have two chords that intersect with each other inside the circle, the following equation is true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement rule number 11 in our drawing. Why? Because in our drawing, we have chord AB. This is actually also the diameter of the circle. Chord AB intersects with chord QM at point C. This is point C. Repeat again, chord AB intersects with chord QM at point C. So I write it down. In our original drawing, chord AB intersects with chord QM at point C. So, therefore, because of the fact that in our original drawing we have two chords that intersect with each other inside the circle, we can implement here rule number 11. According to rule number 11, the following equation will be true. AC times CB will be equal to QC times CM. Repeat again, AC times CB will be equal to QC times CM. Repeat again, according to rule number 11, in our original drawing, AC times CB equals to QC times CM. Here we will define the length of line segment CM as B. So according to rule number 11, this will be equation number 1. AC is equal to 5 times CB. CB equals to 2x minus square root of 5. And it is equals to QC is 5 times CM. CM equals to B. So, in conclusion, according to rule number 11, we found out that square root of 5 times 2x minus square root of 5 equals to 5b. This is equation number 1. We will divide this equation number 1 by square root of 5. And we'll get that according to equation number 1, 2x minus square root of 5 equals to 5b over square root of 5. Here we will add to this equation number 1 square root of 5. And we get that according to this equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. We'll focus on this side of equation number 1. Here we will multiply square root of 5 by square root of 5, and then we'll divide it by square root of 5 in order to overcome a common factor with this expression. And we get that according to equation number 1, 2x equals to 5b over square root of 5 plus, here we'll multiply square root of 5 by square root of 5, and then we'll divide it by square root of 5, so we change nothing. Therefore, the operation is allowable. Repeat again. Here we multiplied square root of 5 by square root of 5, and then we divide it by square root of 5, so we change nothing. So in conclusion, actually we found out that according to equation number 1, 2x equals to 5b plus square root of 5 times square root of 5 is 5 over square root of 5. So here we will divide this equation number 1 by 2. And finally we will get that according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. I will remind to you that x is the radius that we are looking for. We are looking for the length of the radius of the semicircle is equal to x units according to our definition. In the next step, we will join points S and M together by a straight line. Actually, in the drawing, we have peripheral angle MQS. This is peripheral angle MQS that is equal to 90 degrees in its size. And we have rule number 5 that relates to any peripheral angle that is equal to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In the drawing we have a circle. Inside the circle we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees in its size. Therefore, according to this rule number 5, this peripheral angle MAN must rest on the diameter of the circle. From the drawing itself, it is very easy to see that this peripheral angle MAN rests on chord MN. And therefore, according to rule number 5, chord MN must be the diameter of the circle. Indeed, chord MN it is the diameter of the circle. Why? Because chord MN passes through point O, that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. So here we can see that whenever you have peripheral angle that's equal to 90 degrees in its size, then it must rest on the diameter of the circle. Here you can see that the peripheral angle MN rests on MN, that is the diameter of the circle. So actually we can implement rule number 5 in our drawing. Why? Because in our drawing we have, this is peripheral angle MQS that is equal to 90 degrees in its size. So I write it down. Peripheral angle MQS equals to 90 degrees in its size. Therefore, according to rule number 5, this peripheral angle MQS must rest on the diameter of the circle. It is very easy to see that that peripheral angle MQS rests on chord MS. Therefore, according to rule number 5, chord MS must be the diameter of the circle. So I write it down because of the fact that peripheral angle MQS equals to 90 degrees. Therefore, according to rule number 5, peripheral angle MQS must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle MQS rests on MS. Therefore, MS, according to rule number 5, MS must be the diameter of the circle. According to our definition, the radius of this circle is x, therefore the diameter MS must be equal to 2x. So MS equals to 2x in its length. It is actually the diameter of the circle that is equal to 2x units in its length. So in the next step, I will copy the right triangle MQS in a new page and we will implement on this right triangle MQS the Pythagoras theorem. Here by PT is a version for Pythagoras theorem. I repeat again, I will copy the right triangle MQS in a new page and we will implement on this right triangle MQS the Pythagoras theorem. Side QS of the right triangle QMS equals to 5 units in its length. Side QM in total, it is equals to QC plus CM. That is to say, QM equals to QC, that is 5, plus CM, that is B. So in total, QM equals to 5 plus B. And the hypotenuse MS is equals to the diameter of the circle, that is to say it is equals to 2x. So actually, this is the right triangle QMS that I copied from the original drawing. I repeat again that side QS equals to 5 units in its length, side QM equals to 5 plus B units, and the hypotenuse MS equals to 2x. Is also the diameter of the circle. Here by PT is a version for Pythagoras theorem. This will be equation number 2. According to the Pythagoras theorem, ms squared, that is the square of the hypotenuse, must be equal to qs squared plus qm squared. So ms is 2x, therefore ms squared is 2x squared, and it is equals to qs squared. Qs is 5, therefore qs squared is 5 squared, that is 25, plus qm squared. Qm is 5 plus b, therefore qm squared is 5 plus b squared. So according to equation number 2, 2x squared equals to 25 plus 5 plus b squared. This is according to equation number 2, while according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So we actually can substitute x in this equation, equation number 1, by the value of x that we found here in this equation, equation number 1. Again, we can substitute x in this equation, equation number 2, by the value of x that we found here in equation number 1. X, according to this equation, equation number 1, equals to 5b plus 5 over 2 times square root of 5. Therefore, we can substitute x by 5b plus 5 over 2 times square root of 5 in this equation, equation number 2. We will do it now, and we get that according to equation number 2, 2x squared. So it is 2, and x according to equation number 1 equals to 5b plus 5 over 2 times square root of 5 squared, because it is 2x squared. And that is equals to 25 plus 5 plus b squared. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in this side of the equation, after we cancel 2, we have in the numerator 5b plus 5 squared over square root of 5 squared. Square root of 5 squared is 5. So in total, according to equation, in this side of equation number 2, we have 5b plus 5 squared over 5. That is equals to 25 plus 5 plus b squared equals to 5 squared, that is 25, plus b squared plus 2 times 5b. 2 times 5b is 10b. Plus 10b. So we will open the brackets in this side of equation number 2, and we get that according to equation number 2, in this side of equation number 2, we have 5b plus 5 squared. 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b. So the expression 5b plus 5 squared in total equals to 25b, 25b squared plus 25 plus 50b, all divided by 5. And it is equals to, on the other side of equation number 2, we have 25 plus 25, that is 50, plus b squared plus 10b. So actually, in this side of equation number 2, we have 25b squared over 5 is 5b squared, plus 25 over 5 is 5, plus 50b over 5 is 10b. So in total, in this side of equation number 2, we have 5b squared plus 5 plus 10b. In the other side of equation number 2, we have 50 plus b squared plus 10b. So here we have 10b on both sides of the equation, so 10b will get cancelled. After we cancel 10b, in this side of equation number 2 we are left with 5b squared plus 5. That is equal, on the other side of equation number 2, after we cancel 10b, we left only with 50 plus b squared. Here we subtract b squared from this equation, equation number 2, and we get that according to this equation, equation number 2, 5b squared minus b squared is 4b squared plus 5, that is equals to 50. So here we subtract 5 from this equation, equation number 2, and we get that according to equation number 2, 4b squared equals to 50 minus 5 is 45. So 4b squared equals to 45. Here we will divide this equation, equation number 2, by 4. And we'll get that according to equation number 2, b squared equals to 45 over 4. So b squared equals to 45. 45 is 9 times 5, so we substitute 45 by 9 times 5 over 4. So here we take a root out of this equation, equation number 2, and we get that according to equation number 2, b equals to the square root of 9 times 5 over 4. So actually we found out that b, according to equation number 2, b equals to the square root of 9 is 3 over the square root of 5 is 2. So it is 3 over 2. Inside the root we left only with 5. So in conclusion, we found out that according to equation number 2, b equals to 3 times square root of 5 over 2. That is to say, this line segment CM, that is b, it is equals to 3 times square root of 5 over 2 units in its length. This is according to equation number 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So we'll focus on equation number 1. In equation number 1, we will substitute b by 3 times square root of 5 over 2, because b, according to equation number 2, equals to 3 times square root of 5 over 2. Okay, so according to equation number 1, we have x that is equal to 5b. And b, according to equation number 2, equals to 3 times square root of 5 over 2. This is 5b, this is b, plus 5 over 2 times square root of 5. So actually found out that according to equation number 1, x equals to 5 times 3 is 15, so in total this expression equals to 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. In the next step, we multiply this 5 by 2, and then we divide it by 2 in order to have a common factor with this expression. And we get that according to equation number 1, x equals to 15 times square root of 5 over 2, plus we will multiply 5 by 2, 5 times 2 is 10, and then we will divide it by 2, so we change nothing, all divided by 2 times square root of 5. In the next step, we will move 2 times square root of 5 to the denominator here, and we get that x, according to equation number 1, is equals to 15 times square root of 5 plus 10 over 2 times square root of 5, in total equals to 4 times square root of 5. So actually found out that according to equation number 1, x equals to 15 times square root of 5 plus 10 over 4 times square root of 5. In the next step, we'll substitute 10 by square root of 5 times square root of 5 times 2. And we get that according to equation number 1, x equals to the square root of 5 times 15 plus 10. And 10 is square root of 5 times square root of 5 times 2 over 4 times square root of 5. So actually found out that according to equation number 1, x equals to square root of 5 times 15 plus square root of 5 times square root of 5 times 2 over 4 times square root of 5. In the next step, we'll take square root of 5 as a common factor from those two expressions. So x will be equal to square root of 5 is taken out as a common factor from those two expressions in the numerator. So what is left from square root of 5 times 15 after we took from it square root of 5 as a common factor? What is left is actually 15 plus what is left from square root of 5 times square root of 5 times 2 after we took from it square root of 5 as a common factor. What is left is actually square root of 5 times 2 all divided by square root of 5 times 4. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally, we actually found out that x, that is the radius of the semicircle, equals to 15 plus 2 times square root of 5 over 4 units. In terms of numbers, x, that is the radius of the semicircle, in terms of numbers, it is equals to 4.8680 units. Repeat again. The radius of this semicircle, x equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of this semicircle equals to 4.8680 units. That is a little bit less than 5 units, about 4.9 units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the radius of this semicircle. So in the drawing, we have a semicircle. We also know that PA equals to, line segment PA equals to 6 units in its length, and also line segment PA is tangent to this semicircle at point A. In addition, we know that line segment PQ equals to 4 units in its length, and also line segment PS cuts the semicircle at points Q and S. In addition, we know that line segment QS equals to line segment QC, and this is angle PAB that is equal to 90 degrees in its size, and this is angle SQC that is also equal to 90 degrees in its size. Again, our mission is to find out the radius of this semicircle. So in order to find out the radius of the semicircle, I presented to you a new rule, and we implemented the new rule in our drawing. The new rule is rule number 10. According to rule number 10 is true in any circle. So in any circle, if AB is any chord in the circle and PT is a tangent to the circle, then the following equation is true, that PT square equals to PA times PB. So here we have a circle and we have the common external point, point P. From the common external point, point P, we have tangent PT. Tangent PT is tangent to the circle is point T. And from the same point, point P, we have line segment PB that cuts the circle at points A and B. So in this drawing, the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule number 10 in our drawing. Why? Because in our drawing, we have the common external point, point P. From the common external point, point P, we have tangent PA that is tangent to the semicircle point A. And we also, from the same common external point, point P, we have line segment PS that cuts the semicircle at points Q and S. So all the requirements of rule number 10 are met. Therefore, we can implement in our drawing rule number 10. According to rule number 10, PA square equals to PQ times PS. Repeat again, according to rule number 10, if you focus on the common external point, point P, PA square equals to PQ times PS. PA is 6, therefore PA square is 6 squared, that is 36, and it is equal to PQ. PQ is 4 times PS. What is the length of PS? From the drawing it is very easy to see that PS equals to PQ plus QS. So PS equals to PQ, that is 4 plus QS. So in total PS equals to 4 plus QS. Here we substitute PS by 4 plus QS. So in conclusion, we found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we divided this equation by 4. And finally we found out that 36 over 4 is 9, and 9 equals to 4 plus QS. Here we subtracted 4 from this equation. And finally we found out that 9 minus 4 is 5, so QS equals to 9 minus 4, that is 5. So here, chord QS equals to 5 units in its length. But because of the fact that it is given us in the question that QS equals to QC and QS equals to 5, therefore QC must be also equal to 5 units in its length. Then I presented to you rule number 3, and we implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. In the drawing we have the straight line AB. So if we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle alpha and beta. So according to this rule number 3, alpha plus beta must be equal to 180 degrees. We actually can implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. Then we join points P and C together by straight line. By joining points P and C, we created the right triangle, triangle PQC. So I copied the right triangle PQC in any page and we implemented on this right triangle, triangle PQC the Pythagoras theorem. This is the right triangle PQC that I copied from the original drawing. Side PQ equals to 4 units according to what is given as the equation, and we just write down found out that QC equals to 5 units in its length. Here by PT is a version for Pythagoras theorem, so according to the Pythagoras theorem, PC square equals to PQ square plus QC square. So PC square equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC square is 5 squared, that is 25. So in total, PC squared equals to 16 plus 25, that is 41. In conclusion, found out that PC squared, it is the square of the hypotenuse, equals to 41. Then I copied the right triangle PAC in a new page and we implemented the Pythagoras theorem in this right triangle PAC. Okay, so here, this is the right triangle PAC that I copied from the original drawing. Side PA equals to 6 units according to what is given as the question. And PC squared equals to 41. Repeat again. PC squared equals to 41 according to what we have already found out. So in the right triangle PAC, according to the Pythagoras theorem, PC squared equals to PA squared plus AC squared. So PC squared is 41, therefore we can substitute PC squared by 41, and it is equal to PA squared. PA is 6, therefore PA squared is 6 squared, that is 36, plus AC squared. Here we subtracted 36 from this equation, and finally we found out that AC squared equals to 41 minus 36, that is 5. So AC squared equals to 5. We took out of this equation and finally found out that AC equals to the square root of 5 units. So the length of side AC is square root of 5 units. So I can write down in the original drawing that AC equals to the square root of 5 units in its length. Actually, because of the fact that this is a semicircle, AB must be the diameter of the semicircle. If we define the radius of this semicircle as x, if the radius is x, then the diameter AB must be equal to 2x. Okay? So what is the length of line segment CB? From the drawing it is very easy to see that CB equals to AB minus AC. Again, CB equals to AB minus AC. Repeat again. CB equals to AB minus AC. That is to say, CB equals to AB, that is 2x, that is the diameter of the circle, minus AC. AC equals to the square root of 5 units. So in total, CB equals to 2x minus square root of 5 units. So can I write here that the length of line segment CB equals to 2x minus square root of 5 units. Okay? Then we completed the semicircle to a circle, and we extended side QC by side line until it touches the circle. We define the touching point of the extended side QC with this circle as M. Then I presented to you rule number 11, and we implemented rule number 11 in our drawing. So, according to rule number 11, if chord AB intersects with chord CD at point O, then the following equation is true. That AO times OB equals to CO times OD. Again, whenever we have two chords that intersect with each other inside the circle, then the following equation will be true. Here chord AB intersects with chord CD at point O. Therefore, according to rule number 11, AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. Repeat again. In our original drawing, we have chord AB intersects with chord QM at point C. Therefore, according to rule number 11, we'll get that AC times CB equals to QA, AC times CB equals to QC times CM. Again, AC times CB equals to QC times CM. Repeat again, according to rule number 11, AC times CB equals to QC times CM. AC equals to the square root of 5 units, CB equals to 2x minus square root of 5, QC is 5, and CM equals to B according to our definition. So in conclusion, found out that according to equation number 1, square root of 5 times 2x minus square root of 5 equals to 5b. Here we divided this equation number 1 by square root of 5, and finally found out that 2x minus square root of 5 equals to 5b over square root of 5. Then we added to this equation number 1 square root of 5, and found out that according to equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. In the next step, we multiplied square root of 5 by square root of 5, and then we divided by square root of 5 in order to have a common factor in this expression. So here we have 5b over square root of 5, and here we multiply square root of 5 by square root of 5, and then we divide it by square root of 5, so we change nothing. And actually we found out that according to equation number 1, 2x equals to 5b plus square root of 5 times square root of 5. Square root of 5 times square root of 5 is 5. So in total, according to equation number 1, 2x equals to 5b plus 5 over square root of 5. Then we divided this equation number 1 by 2, and finally found out that x equals to 5b plus 5 over 2 times square root of 5. I remind to you that x is the radius that we are looking for. According to our definition, x is the radius of this semicircle, and we have to find out the value of x. Okay? In the next step, we join points S and M together by a straight line. So, in the drawing we have peripheral angle MQS. This peripheral angle MQS equals to 90 degrees in its size. And we have rule number 5 that relates to any peripheral angle that is equal to 90 degrees in its size. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So inside this circle we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees in its size. So you can see in the drawing. Therefore, according to this rule number 5, this peripheral angle MAN rests on the diameter of the circle. From the drawing it is very easy to see that peripheral angle MAN rests on chord MN. And therefore, according to rule number 5, this chord MN must be the diameter of the circle. And indeed, from the drawing itself, MN passes for point O, that is the center of the circle. Therefore, MN must be the diameter of the circle. Why? Because any chord that passes for the center of the circle must be the diameter of the circle. So, in conclusion, whenever we have peripheral angle that is equal to 90 degrees, then that peripheral angle must rest on the diameter of the circle, exactly according to this drawing. Peripheral angle MAN that is equal to 90 degrees rests on MN, that is the diameter of the circle. We can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS that is equal to 90 degrees in its size. Therefore, this peripheral angle MQS rests on the diameter of the circle. From the drawing it is very easy to see that peripheral angle MQS rests on MS. Therefore, according to rule number 5, MS is the diameter of the circle. I repeat again, because of the fact that peripheral angle MQS equals to 90 degrees in its size, according to rule number 5, peripheral angle MQS must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle MQS rests on MS. Therefore, MS must be the diameter of the circle according to rule number 5. And because of the fact that the radius of the circle and the semicircle equals to x according to our definition, therefore the diameter must be equal to 2x. That is to say the diameter MS equals to 2x. The diameter MX equals to 2x units in its length. Then I copied the right triangle MQS in a new page and we implemented the Pythagorean theorem in this right triangle MQS. Side QS for the right triangle MQS equals to 5 units in itself. Side QM in total equals to QC plus CM. That is to say QM equals to QC, that is 5, plus CM, that is B. So in total QM equals to 5 plus B. and the diameter ms, according to rule number 5, actually the hypotenuse, that is also the diameter of the circle, it is equal to 2x units in its length. So actually this is the right triangle MQS that I got it from the original drawing. I repeat again that side QS equals to 5 units in its length. We have already found out that side QM equals to 5 plus B units in its length. And the hypotenuse MS, it is also the diameter of the circle that is equals to 2x units in its length. Implemented here the Pythagoras theorem. According to the Pythagoras theorem, SM or MS square equals to QS square plus QM square. Again, MS square equals to QS square plus QM square. MS is 2x, therefore MS square is 2x square, and it is equals to QS square. QS is 5, therefore QS square is 5 square, that is 25, plus QM square. QM is 5 plus B, therefore QM square is 5 plus B square. So in conclusion, according to equation number 2, we found out that 2x squared equals to 25 plus 5 plus B squared. Well, according to equation number 1, we have already found out that x equals to 5b, x equals to 5b plus 5 over 2 times square root of 5. Now we can substitute x in this equation number 2 by the value of x that we found here in equation number 1. According to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. Okay, so according to equation number 2, we will get that here we have 2x squared, and x according to equation number 1 is 5b plus 5 over 2 times square root of 5 squared. And it is equal to, according to equation number 2, it is equal to 25 plus 5 plus b squared. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. After we cancel 2, we have here in the numerator 5b plus 5 square over square root of 5 square. Square root of 5 square is 5. So in total, in this side of equation number 2, we have 5b plus 5 square over 5, that is equal to 25 plus 5 plus b square. 5 plus b square equals to 5 square, that is 25, plus b square plus 2 times 5b, that is 10b. Then we open the brackets on this side of equation number 2 and found out that according to equation number 2, 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b, that is 10b. 10b times 5 is 50b. So this expression in this side of equation number 2, the expression is in total equals to 25b squared plus 25 plus 50b, all divided by 5. In the other side of equation number 2, we have 25 plus 25, that is 50, plus 25b plus 10b again. In the other side of equation number 2, we have 50 plus b squared plus 10b. So here we have 25b squared over 5 is 5b squared, 25 over 5 is 5, and 50b over 5 is 10b. That is equal to 50 plus b squared plus 10b. So here we have 10b on both sides of the equation, so 10b will get cancelled. After we cancel 10b, in this side of the equation we left only with 5b squared plus 5, and the other side of the equation we left only with 50 plus b squared. So according to equation number 2, we found out actually that 5b squared plus 5 equals to 50 plus b squared. Here we subtract the b squared from this equation number 2, and finally found out that 5b squared minus b squared is 4b squared. So here we have, in this side of the equation, we have left with 4b squared plus 5, and the other side of the equation we left only with 50. So according to equation number 2, 4b squared plus 5 equals to 50. Here we subtracted 5 from this equation, and finally found out that 4b squared equals to 50 minus 5 is 45. So according to equation number 2, in conclusion found out that 4b squared equals to 45. Here we divided this equation number 2 by 4, and finally found out that b squared equals to 45 over 4. So b squared equals to 45. 45 is 9 times 5, so we substitute 45 by 9 times 5. divided by 4. We took the root of this equation and finally found out that b equals to the square root of 9 times 5 over 2. 9 times 5 over 4. The square root of 9 is 3. And over 4, the square root of 4 is 2. So in total we found out that actually b equals to 3. So inside the root we left only with 5. So in conclusion we found out that according to equation number 2, p equals to 3 times square root of 5 over 2. This is according to equation number 2, while according to equation number 1, we have only found out that x equals to 5b plus 5 over 2 times square root of 5. So now we can substitute b in this equation number 1, by the value that we found for b in this equation number 2. And we get that according to equation number 1, x equals to 5b, and b according to equation number 1 equals to 3 times square root of 5 over 2. Okay, so this is b, and we have also plus 5 over 2 times square root of 5. So here we have 5 times 3, that is 15, so in total this expression equals to 15 times square root of 5 over 2, plus 5 over 2 times square root of 5. Here we multiplied 5 by 2 and then we divided by 2 in order to account factor with this expression. And found out actually that x, according to equation number 1, x equals to 15 times square root of 5. And here we have 5 times 2 is 10, divided by 2. So it is 10 divided by 2. We multiplied 5 by 2 and then we divided by 2, so we change nothing. So according to equation number 1, x equals to 15 times square root of 5 plus 10 over 2. All divided by 2 times square root of 5. Then we moved 2 times square root of 5 to the denominator. 2 times square root of 5, 2 times square root of 5 in total equals to 4 times square root of 5. So in the denominator we have 4 times square root of 5. In the numerator we have 15 times square root of 5 plus 10. So here we substitute 10 by square root of 5 times square root of 5 times 2. So according to equation number 1, we found out that x equals to square root of 5 times 15 plus 10. And 10 equals to square root of 5 times square root of 5 times 2. All divided by 4 times square root of 5. Here we took out square root of 5 as a common factor from those two expressions in the denominator. So what is left from square root of 5 times 15 after we took from it square root of 5 as a common factor? What is left? It is actually 15. And what is left from square root of 5 times square root of 5 times 2 after we took from it square root of 5 as a common factor? What is left? It is actually square root of 5 times 2. All divided by square root of 5 over all divided by square root of 5 times 4. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we found out that actually x equals to 15 plus 2 times square root of 5 over 4 units in its length. Or in terms of numbers, x, that is the radius of this semicircle, equals to 4.8680 units. I'll repeat again. The radius x of this semicircle equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of this semicircle equals to 4.8680 units in its length. That is to say, it is almost 4.9 units in its length. Okay, thank you very much.